Good afternoon, everybody. Now let us start our complex integration. Okay, this is your complex integration. This is from Unit 1, Core 13, first section, máthēma students. Okay. So, what do you mean by complex integration? So, first we will come to its definite integral. A definite integration. So, what we will do in definite integration? If the upper limit and lower limit is given to you, then you can say that is a definite integration. Now we will try how to solve this type of problems. Okay. Now first I will give a definition which says that let f of t which is equal to u of t plus v of t be a continuous complex valued function, be a continuous complex valued function. This is a continuous complex valued function defined on close AB. Defined on close AB. Then you can say integration from a to b f of t dt. This thing is equal to integration from a to b u of t dt plus integration from a to b v of t dt. Okay. Or if you can write f of t is there u of t plus I times v of t, then integration from a to b f of t dt is equal to integration from a to b ut dt plus I times. Okay, since we are studying complex analysis, so if this is a complex function, then integration of left hand side is same as this one from the right hand side. Okay. So now comes to a lemma. So what is the lemma now? So I will go to a different window. So what is the lemma is saying? The lemma says integration from a to b your f of t dt modulus is less than equal to integration from a to b mod of f of t dt. Mod of f of t dt. So how will show this thing? Okay, now we'll come to its scope. So let integration from a to b your f of t dt is equal to r e to the power I theta. Okay, let integration from a to b f of t dt is your r e to the power I theta. This implies integration from a to b f of t dt modulus. This will be your r, because e to the power I theta modulus you know already. E to the power I theta means this is cos theta plus I sin theta. Then its modulus means cos theta plus I sin theta's modulus, which is your cos square theta plus sin square theta, which is your 1. Okay, so e to the power I theta modulus is 1. So modulus of right hand side is only r. This is r, not v. This is your r. So you can add your r is equal to, if r into e to the power I theta is your this one, so what will be your r? This is e to the power minus I theta into integration from a to b f of t dt. Okay, so this is your this one, and you know this is, r is a real number, so you can write, or you can come to the left. So this is integration from a to b f of t dt modulus. and the right hand side this is r, this is a real number, and r is this one. So we can say this is the, and this is a complex number. So since r is a real number, so we can write this thing is the real part of e to the power minus I theta of e to the power minus I theta of integration from a to b f of t dt. Okay, so uh, since r is real and this real part is this one, so I can write this is the real part of this one. So then what we can write, e to the power I theta can go to inside, because since we are taking integration of f of t is continuous, so this e to the power I theta can go inside of this integration. So I can write this is integration from a to b e to the power minus I theta f of t dt. Okay, now what is the real part of this one? E to the power I theta f of t dt, real part of this one. Or you can say this is integration from a to b, this is the real part of e to the power I, e to the power minus I theta f of t dt. Okay, this real part also can go to inside of this integration. Then what we can write, the real part of this one we know already. If z is your x plus I y, then real z, whatever is if z is this one, then real z is always less than its modulus. Its modulus is x square plus y square root over. So we always know that real z is always less than mod z. Similarly here a real part of this thing is always less than its modulus. So we can write this thing is less than integration from a to b. In place of real part of this thing, I will write this thing is less than its modulus. So what is its modulus? This is e to the power minus I theta f of t dt. Okay, modulus of this one, and since I use this thing, so this is less than equal to symbol is there. So then what we can write, modulus of this one is equal to integration from a to b, this is e to the power minus I theta modulus into f of t modulus, then dt, and it e to the power I theta modulus is your 1. So we can write this thing is only f of integration from a to b, this is f of t modulus, f of t modulus, then dt. Okay, so now our proof is completed. We just started from here, and less than equal to symbol is there, and then final we got this one. So we can write this implies integration from a to b f of t dt whole modulus is less than equal to integration from a to b f of t modulus dt. Okay, so this thing is completed. Now comes to another definition. So come to the next page. So what is your another definition? So it says how to find a line integral. So let's see be a piecewise differentiable curve. C be a piecewise differentiable curve. Let C be a piecewise differentiable curve given by the equation C equal to or Z is equal to Z of t. Okay. See, the equation of the curve is given by Z is equal to Z of t. That means Z is a function of t where t lies between a to b, or t varies from a to b. Let f of z be a continuous complex valued function. Let this f of z whose integration you have to do, that f of z be a continuous function, continuous, since it is a complex valued, so we can say this is a continuous complex valued function. This is a continuous complex valued function defined in a region containing the curve C. Okay, that is, you have to integrate this f of z over C, and here it is saying that f of z is continuous. F of z is a continuous complex valued function defined in a region containing C, containing this curve C. That means in this curve C, this f of z is continuous. Okay, so then we can define, because whatever the integration or what function is given, you have to integrate that function if that f of z is continuous. Okay, so we can write, we have integration over C f of z dz. This is the defineness of integration over a curve C. So what is the defineness? Integration over C f of z dz, and you know z is given as z of t, so you can write this thing as integration from a to b. Z is equal to z of t and t varies from a to b, so you can add this is integration from a to b and use this variable z of t. This is f of z equal to f of z of t. This is f of z of t. Okay. F of z of t, then dz means z is a function of t, so dz means this is z dash t, then dt, just like your chain rule. Okay, so this is the line integral, or this is the integration over a curve C. Integration over C f of z dz is equal to integration from a to b f of z of t z dash t dt. Okay, so now I will see a small example. Consider integration over C f of z dz. Okay, so where f of z is here 1 by z, and what is the curve C? Curve C is a circle. This is mod z equal to r. So what do you mean by mod z equal to r? So mod z equal you know, in generally, if somewhere it is given that z minus a modulus is equal to r, that means you have to understand that this is saying this is a circle whose center is a, whose center is equal to a and radius is equal to r. So z minus a modulus equal to r, that means you can write this is z minus a equal to r e to the power I theta. Okay, because if you will take its modulus, the right hand side will be r and z minus a modulus is z minus a. So z minus a modulus equal to r implies z minus a equal to r e to the power I theta, then z is equal to a plus r e to the power I theta. So always remember these things. That means this is the circle whose center at a and radius is r. Okay, so if mod z equal to r is given to you, that means this is a circle. That means this is z minus 0 equal to r. That means this is a circle whose center is 0 and radius is r. So if we will go to its equation, this will look like this. That means you will write your z is equal to r e to the power I theta, and where this theta is a full circle, so theta will vary from 0 to 2 pi. Okay, so here the equation of the curve is mod z equal to r. That means this is z minus 0 equal to r, or z is equal to r, or z is equal to, if you will remove this modulus, then you will write z is equal to r e to the power I theta, where theta varies from 0 to 2 pi, complete circle. Okay, so f of z is equal to this one, and this curve is equal to this one. This is a circle. Then and this since we have taken here the variable is t, so you may write this is e to the power it. Okay, So you may write this is e to the power it, and t varies from 0 to 2 pi. So if this is your z, then what will be your z dash t? That means you just take its derivative with respect to t. So z dash t will be, r is constant, e to the power it's derivative with respect to t is I e to the power it. So now we will write its solution. Integration over c f of z dz is equal to integration, and here, okay, this is z dash t, and here t varies from 0 to 2 pi. So my limit will be 0 to 2 pi. And what is your f of z? F of z is your 1 by z. So this is 1 by z, and what is the value of z? Z is r e to the power I theta. Okay, e to the power it, 1 by r e to the power it. Then what is your z dash t? Because integration over c f of z dz is your this one. This is a formula you have to remember. So f of z of t is this one. Then what is z dash t? Z dash t is evaluated here. This is I r e to the power it into dt. Okay, dt is here. So there are something which will cancel out. R e to the power it, r e to the power it will cancel out. So only left will be I. So I is a constant. We can take it outside of this integration. So this is of dt. So this is I, and integration of dt, this is 1, and t varies from 0 to 2 pi. So this will be 2 pi I. So this is the process how to find the integration. Okay, now comes to another thing. Suppose a small theorem is here. So what is the statement of this theorem? Integration over minus c of f of z dz is equal to integration minus of integration over c f of z dz. Okay, this thing generally looks like obvious, but sometimes in your exam it will ask, so we will prove it. Okay, then we will write its proof. Let c be the curve given by, so what is the equation of c? Let equation of c, or the curve c is given by z is equal to z of t, where t varies from a to b. Okay, suppose this is given to you, because c is given to you, and you have to integrate over minus c is equal to minus of integration over c. So then the equation of minus c will be, so if equation of c will be this one, then equation of minus c will be z of t is equal to z of b plus a minus t. Okay, so c means this is curve, and minus c means just is negative curve. That means suppose if c is a curve, suppose this is this is a, this is b. If c is like this, then minus c will be come in its opposite direction. That means if c is going in this way, like from a to b, suppose this is the position a, and this is the position here b, f of b. So if c is going in this way, and minus c will come on its opposite direction. So when if I will write z of t equal to this one, then you just see, when you will put t is equal to a, what you will get? Z of a will be, in place of t, if you will write a, then this will be z of b. Similarly, if you will put t equal to b, then z of t will be here. In place of t, you just write b, then b cancel out, you will get z of a. Okay, so the equation of minus c will be z of t equal to z of b plus a minus t, where t varies from a to b. Then this will be the curve for minus c. Okay, so now consider or integration of minus c of f of z dz. And what will be this one? This will be integration from a to b. And what is f of, in place of z of t, we will write this thing, f of z of a plus b minus t, a plus b minus t. Then we are writing z dash t. So z dash t means this will be z dash of, in place of t I will write this thing, z dash of b plus a, or a plus b minus t, whatever it may be, b plus a minus t. Then what is the derivative of this thing which is inside bracket? This will be minus dt. Okay, whatever inside this bracket I am taking derivative of that thing, so that will be minus t, minus dt. Okay, so then what we will write here? Now we will put this b plus a minus t is equal to u. Then your minus dt will be du, and here you see that when your t is equal to a, your u will be b, and when t is equal to b, then your u will be a, then u is equal to a. That means it is reversing. That means when for t, when you are writing from a to b, and when t is equal to, at that time u is equal to b, so when and t equal to b, at that time u is equal to a. So the above integration I can write here. If I will change this thing in this variable u, or I am changing or replacing t by u variable. So when t is equal, t varies from a to b, at that time u varies from b to a. So I can write this is b to a. Then f of z of u, I am taking this thing as u. Okay, so f of z of u, and this is z dash u, this one, this is u, and minus dt is your minus dt your is your e du. Okay, so now this thing, so I can add, this is minus of integration from a, since it is b to a. So if I will change my integration, upper limit as lower limit and lower limit as, and that means if I can interchange, then I will give a negative sign there. Then this will be f of z of u, then z dash u du, and which is your, from the definition, this is from integration minus of c f of z dz. Okay, so that means we got integration over minus c of f of z dz is equal to minus of integration over c f of z dz. Okay, now comes to next page. Now how we will find length of a curve? Length of a curve. So how we will find length of a curve? Now comes to definition. Let C be a piecewise differentiable curve given by the equation. Let C be a piecewise differentiable curve. Let C be a piecewise differentiable curve given by z is equal to z of t. Z is a function of t, where t varies from a to b. Okay, this is given to use the equation of the curve C. Then the length L of the curve C is given by, then the length L of the curve C is given by, so what is the length of that curve? Just remember, this is the formula, integration from a to b, this is z dash t modulus dt. So whatever is the curve of equation of that curve, we just take that's derivative and then take its modulus, then you will take its integration from a to b, or where from which to which number that t varies. Okay, so now comes to an example. Okay, you will use this definition, or you will just remember this thing. Now by using that definition or that formula, I will find a length of a problem or length of a curve. So consider a circle. Suppose a circle is given to you whose center C is a circle. C is a circle whose center is 0 and radius is r. That means it is the equation of the curve. Z is equal to mod z equal to r. It means the equation of the curve is, that means the equation of the curve is mod z equal to r. That means this is a circle whose center is 0 and radius is r. So if mod z equal to r, this is your curve. Sorry, center is a. Center is a and radius is r. So what will be the equation of the curve? Then the equation of the curve will be z minus a modulus is equal to r. So z minus a modulus equal to r. That means z minus a is equal to r e to the power I theta, or you may write it. I am using the variable t always here. So this will be it. That means your z is a plus r e to the power it, where this t varies from, this is 0 to 2 pi. T varies from 0 to 2 pi. Now what will be my z dash t, because I will use this z dash t. So if z is your this one, then what is your z dash t? This will be r. Derivative of a is constant, so derivative of a will be 0. Then r e to the power it is derivative is I e to the power it. Okay, so now length will be integration from a to b, where the t varies from 0 to 2 pi. So you may write this is 0 to 2 pi and z dash t modulus dt. That is integration from 0 to 2 pi. So z of t is your this one. Then what is its modulus? Z dash t modulus is modulus of this one I r e to the power it, and modulus of I is 1, you know, and r is r, and e to the power it is modulus is 1. So this will be simply r. So modulus of z dash t is simply r. Then dt, then this will be r. R is constant, it can go outside of this integration. Then this is only t, integration of dt, or integration of 1 is t. This is 0 to 2 pi, so this will be 2 pi r. This thing you already know. If suppose a circle is given to you whose center is a and radius is r. Suppose this is a circle, this is a and its radius is r, this is your r. Then what is the length of this circle or length of this curve? I am saying the curve is a circle. So since its radius is r, so you know its perimeter is 2 pi r, and this is its length. Okay, what we got here? This is the length of this curve. That means the length of this circle whose center is a, whose radius is r. You know its perimeter is 2 pi r, so this is the thing. Now comes to next page. Then I will go to a theorem. So now I will write the statement of this theorem. Integration over c f of z dz modulus, integration over c f of z dz modulus is less than equal to ml. Okay, so what is m and what is l? Here m is the maximum value of f of z, maximum value of mod f of z. This is the maximum of mod f of z such that z belongs to c. C means z belongs to this curve. So within this curve, what are the values of z is you are getting? F of m is the maximum value of that f of z, where z belongs to this curve C. Okay, that is the value of m. Then what is L? And L is the length of C. So integration modulus of integration over C f of z dz is less than m into L, where m is the maximum value of f of z, where z belongs to this curve C, not this complex number C. Z belongs to this curve C, and L is the length of that curve. Okay, now we will prove this one. Suppose C is given by the equation, the curve C is given by the equation z is equal to z of t, where t varies from at a to b. Suppose this is the curve C, then by definition what is your m? By definition m is equal to maximum of m is equal to, it is already saying here, m is equal to maximum of f of z modulus such that z belongs to this curve C. Okay, or you may say that by definition m is equal to this one, where t varies from a to b. So this implies you may say that modulus of f of z is always less than m for all z belongs to curve C, or for all t lies between a to b, mod of f of z is always less than equal to m. Okay, now we will consider the integration from sorry. Now we will consider integration over C f of z dz, f of z dz modulus, which will be equal to integration from a to b f of z of t z dash t dt whole modulus. Whole modulus is given to just f of z dz is your this one. Since z is a function of t, then you can write this thing is less than equal to, so if modulus will go inside of this integration, then I will write this is integration from a, here C varies from a to b, that's why I put that limit here. Okay, so if the integration, if the modulus will go inside of this integration, then less than equal symbol will be here, then this thing is less than equal to integration from a to b f of z of t, then z dash t whole modulus dt. Then you can take their individual modulus. This thing will equal to integration from a to b, this is f of z of t, then this is z dash t modulus dt. Then you know the maximum value of f of z of t. Okay, this is the maximum value of f of z of t, this is m. So I will use a less than equal to symbol here. So this will be integration from a to b, and you will write this is m, that's why I use the less than equal to symbol m. Then z dash t dt, z dash t modulus dt. Also you can take this m outside of this integration, then it will be integration from a to b z dash t mod dt, and this is your L. So you can write this is your L. Okay, so whatever you will get, whatever you are getting is integration over C, this is integration over C of f of z dz whole modulus is less than m into L. These are the some theorems you have to remember, or you have to say these things. Okay, today is only this much, and the next class we will see some problems where we will Here we will find length of some curve or we will find some definite integrals.